Okay, so right now I want to try a more advanced example. In this example, we have two objects in motion, and they're displaying different types of motion. That's what makes it challenging. I have one object which is undergoing constant speed, and one object which is undergoing constant acceleration. So here's what my problem says. A car speeds down a road at 35 meters per second. It passes a police car which is at rest. After 3 seconds, the police car begins chasing the speeding car, which does not change its speed. The police car catches up to the speeding car after it, meaning the police car, has traveled 805 meters. And we're going to find three things. First, how long the police car was in motion. Second, what the police car's acceleration was. And finally, what was the police car's final speed when it catches the speeding car. And just note, it's not going to be 35 meters per second. So let me get a clean page and we're going to start to solve the problem. So what's going to help us with this is recognizing some couple of things about the police car and the speeding car. First thing that's going to be important is they're both going to travel the exact same distance. How do I know that? Because the police car catches the speeding car. Therefore, they have to have gone the same amount of distance. The second thing that's important is the speeding car travels for 3 seconds longer than the police car. With those two things in mind, I can solve the problem. Now, let's work on the first part, which is how long is the police car in motion? We just said that the speeding car, which I'm going to call C, is in motion 3 seconds longer than the police car, which I'm going to call P. So let's find out how long was the speeding car in motion. We know that the speeding car was traveling with constant speed. So that's V equals X over T, or T is X over V. I know how far my speeding car traveled. It traveled 805 meters at a speed of 35 meters per second. Hit that into my calculator, and I get that my speeding car was traveling for 23 seconds. That means my police car was traveling for 3 seconds less, or 20 seconds. So that's the answer to the first part. Police car traveled for 20 seconds. I can now use that to help me get my acceleration. Okay, so here's what I know about my police car. First of all, I know it traveled for 20 seconds, which is what we just found. I know it went a distance of 805 meters, and I know it started from rest. From this information, and using my kinematics equations, I can figure out what its acceleration was. So the big question is, which kinematics equation do I want to use? We have 3 of them. Well, if you're looking at your formula sheet, you can see that the first equation, VF equals VI plus AT, can't use because I don't have VF. And likewise, I can't use the third equation for the same reason. I don't have VF. So that means I have to use the middle equation. X equals VI T plus 1/2 A T squared. Now that looks like it's going to be pretty complicated until you remember that VI is 0, so that entire term drops out of the equation, leaving us with X equals 1/2 A T squared, or A equals 2x over t squared. So if I plug in, that's 2 times 805 over 20 squared. I hit that into my calculator, which I've already done, and I come up with an acceleration of approximately positive 4 meters per second squared, which is a pretty fair acceleration for a car. Okay, now the last thing that I'm asked for is the police car's final velocity. Now I can go about that either of a few different ways. The easiest thing for me to do is to plug into VF equals VI, which again was 0, plus AT. Can I use my other equation? Yes, I can use VF squared equals VI squared plus 2AX. Again, VI is going to drop out, but I'd have to worry about taking the square root. Always go with the simplest way. So I'm going to plug in VF equals AT. So 4 times 20. And you'll see that our police car, by the time it catches it, is actually going 80 meters per second. Okay, that's really fast. That's going to be like about 170 miles per hour, which is probably not likely, but it could happen. Now, why isn't it traveling the same speed? Well, that should make sense that it's not traveling the same speed as the car, because, number one, it has to go the same distance in a shorter amount of time. And because it was starting from rest, to get that same average speed, it's going to have to be going much faster at the end. Now, another way that I can interpret this is if I were to draw a graph, which we did in a previous exercise. So let me just erase a little bit here. Get myself some space, and I will just do a quick little sketch of a graph to show you. There we go. Okay. So my car, its velocity would look like this. Now this is going to be a VT graph, so it would have a constant velocity. My police car, on the other hand, would be starting from rest and then would be accelerating. Now remember, we said that the area under the graph is the distance that it traveled. So my car in those 23 seconds would have an area, this is 35, this is 23, 35 times 23 is going to give me 805. Area for the car. I would have to have the same area for 20 seconds, okay, for my police car. And my police car, this is a triangle, so I would have to say the area is 1/2 the base times the height. We know that the base is 20, so 1/2 times 20, okay, is going to be 10. So my height, in order to give me an area of 805, my height would have to be 80.5 meters per second, which is very close to what I had solved for. Okay, we rounded in a few places, which is why it isn't exact. Okay, so if you have any questions, please send me an email or ask me when you see me in class. Thanks.